Thank you for joining us. I am Shilpi Puri, your host for today. Before we start, let me quickly explain you the structure of the webinar. The total duration of today's webinar is about 55 minutes. We have a presentation for 25 minutes, followed by a demo that will take about 15 minutes. 5 minutes for the introductions, and we'll keep about 10 minutes of time for questions and answers. If anybody has a question during the presentation or the demo, I request you to please type in and send your question to me over chat or through the Q&A panel. We will take up the questions during our Q&A session at the end of the presentations and demo. Um, now, let me introduce our speakers for the day. We are pleased to have with us Dr. Claudia Imhoff. Claudia is an internationally recognized expert on analytics, business intelligence, and the infrastructure to support these initiatives. She's a popular speaker and has co-authored 5 books on these subjects. She has also authored many articles for different technical magazines. She is a fellow and advisor for the Data Warehousing Institute and has delivered keynote addresses at conferences throughout the world. Thank you so much for joining us, Claudia.
Well, thank you, Shelby. And my thanks to Intellicus for inviting me to the party. This is fun. We're going to have, I think, a very good talk today.
Sure. We also have with us Rajesh Murthy, Vice President of Engineering at Intellicus Technologies. Rajesh is the founder architect of Intellicus. He takes care of product management and development at Intellicus. Thank you for joining us today, Rajesh.
Hey, thank you, Shilpi. Hi, everyone. Very good morning to all of you.
All right, so let's get started. I request all the attendees to please be on mute, and over to you, Claudia.
Okay, thanks so much, Shilpi. And again, my thanks to Intellicus. It's always fun to meet a new company and to learn all about them, and they're a very clever company. Let me start off my part, at least, with some standard definitions, if you will, for our industry. This area is relatively new. We have this new stuff called artificial intelligence, theory and practice of building computer systems that can perform amazing feats, normally require human intelligence and so forth. Things like chatbots, virtual assistants, even smart cars. The other one that is relatively new and confusing to a lot of people is the Internet of Things, or IoT, a network of connected devices collecting and interpreting data all over the Internet. And again, some examples here are predictive maintenance. When do we think a part may be failing or will fail? Asset monitoring and risk assessment. These are all examples of how we're using the IoT environment today. Now let me drill down a little bit into 3 very important forms of analytics. The first one is probably the oldest in the whole group, without a doubt, and that's predictive analytics. Good old statistics. Statistical or computational science techniques used on structured or unstructured data today, giving us probabilities of an outcome. And the examples here are customer churn or the next best offer for a customer, readmissions at a hospital, and so forth. The next one is a relatively new kid, machine learning, systems that learn from data. They identify patterns with minimal human intervention. I did say minimal, it doesn't mean no. And the examples here again, customer churn, a really good one is fraud detection. There are also recommendation engines and that sort of thing that learn patterns, understand behaviors, and can recommend things. And then the last one is probably the least understood, and that's deep learning, the algorithms that learn functions to classify complex patterns, being able to classify, for example, images or sound, for example, medical images, retail, and so forth. These are the industries that are now using these types of learnings. We're going to focus predominantly on machine learning, but all 3 come into play when we're talking about using these types of capabilities. Certainly, with data science and machine learning, we can learn from our historical data and understand what happened and why. And of course, once we've got the machine learning, we've got the models trained, we can then begin to say, all right, what's going to happen in the future? We can predict what is likely to happen and figure out, is this a good thing or a bad thing? And if it's a not so good thing, then how about changing the future? Can we do something? So we're trying to figure out these hidden insights in our data, which otherwise we'd never get to know. It certainly helps us look into the future and make decisions that would make it even better. We also have a number of benefits from machine learning. Certainly, we understand that there are many, many different types of data that we want to be able to analyze, unlimited amounts of data in many cases. The consumed data can then be used to constantly review, modify enterprise strategies based on actual patterns and variables. And that's a great benefit of the technical side of machine learning. It's also very good at analyzing problematic data, if you will. Traditional analytic techniques don't handle wide data sets, data with many data points or attributes in every record, and also loosely correlated data. Both of these can present problems for traditional analytical methods. The other thing about machine learning, which I find rather useful, is that the algorithms, the training and so forth, they don't get tired. They don't get grumpy. They don't go home at the end of the day. They continue to work at peak efficiency for as long as it takes. And they don't care how large the data set is or how complex the analysis is or what time of day it is. They just keep working. And you keep training and training and getting more and more insight. We need machine learning to gather as many parameters as are available in the real world, things that perhaps we as humans hadn't even thought of. The machine learning will perhaps pick these out. We also need that historical data, of course, because that's what we use as our baseline, all the data that you or your business might have gathered over the years. Machine-generated data, device-generated data, user data, all these kinds of things, so that we can get a good outcome from your investment in all of that historical data. And, yes, of course, we can always blame the algorithms when things go wrong. It's always useful to have somebody to blame. Machine learning, though, does have its limitations. It's not all it's not all good. It certainly is a very useful technology, but there are some things that it cannot do. For example, a machine is not autonomously creative. It can't spontaneously, if you will, develop new hypotheses from facts, and facts are data, that are not in evidence. It can only use the data that it's got, right? And a machine can't determine a new way to respond to emerging stimuli. That's where the human being has to kick in. The output of the machine learning algorithm is entirely dependent on the data that you give it. If you change the data, you're going to change the results. And we'll see examples of this as we go through the webinar. The bottom line, never fear, the human is still needed in the mix. Yes, we do still need people in this new world of machine learning. Now, how do we use machine learning? Let me give you some use cases here, some interesting situations of how we can use this, the process of machine learning, if you will. Yeah, we need data scientists, by and large, to form algorithms, process the data, and prepare the outcomes. In the traditional setup, only a data scientist and the data science programmers would have access to the machine learning operations. And that's part of the problem, isn't it? More than 50% of their time, in fact, in many cases, it's as high as 80% of their time is taken up by just preparing the data, doing the ETL, moving the data between the data storages, and machine learning systems before even jumping into designing the models and getting the resulting numbers. Even after the predictive numbers are generated, it still takes a lot of manual effort to get the results to the appropriate visualization systems so that the business users can actually understand the outcomes, the results of all these machine learning algorithms. So that means that the business users, the leaders of the organizations, could have a very long wait time before they actually get access to very critical insights so that they can make decisions. And there's this huge dependency on finding the data scientist, getting the data scientist, waiting for them to create this environment for you. So it's more or less this black box experience for business users, and nobody likes that black box experience. Just hand me this and I'll take it at face value. So, can we make machine learning for everyone? Yeah. The goal is to bring machine learning or innovate enough with machine learning to a point where the average business user won't need a data scientist to build these things for them. To do this, though, we're going to have to change the traditional model. The traditional model of the data scientist or the report generator being the only people who have access to machine learning capabilities. We need to make machine learning accessible to everyone. And we are starting to see very innovative companies like Intellicus that are able to bring machine learning into a very simple environment, and you'll see that when Rajesh does his demo. We need to simplify the process, though, first, and that means the complexity of the interface should be hidden from the everyday user. They don't want to see the sausage being made, they just want to enjoy it. And that means that we empower these business users to be sort of data scientist-like. They're not exactly data scientists, but they can certainly run the algorithms, train the models, and understand what's going on if the interface is simple enough for them to use. All right, let's talk about those use cases. Where would I use machine learning? Well, there are many that are very popular. For example, that first one, to quickly predict the next best offer for a customer. Now, that takes a lot of effort. We have to know what they already have. We have to know what their pattern of usage is. Did they buy the next best product that we're about to offer them 2 seconds ago? We don't want to offer them something that they just bought. The next one, increase the efficiency of that predictive maintenance capability. Yes, indeed. Can we determine before something goes wrong that it's about to go wrong and get the part to the machine before it goes bad? Predicting customers' future purchases. What kinds of campaigns would appeal to them? What kinds of products do they want now? And then facilitating more accurate medical predictions is a big one. Predicting and making better diagnoses, huge benefit to the human being. And then the last one is an interesting one, improving precision for financial rules, for financial models, for example, fraud and so forth. Now let's talk a little bit about the process here. It's a 3-pass process. The idea is that it involves machine learning, of course. It involves the evaluation or testing if the learning process is accurate, and then using the models to predict. So let's take a look at how this works. And I'm going to call on Rajesh because he can explain this so much better than I can, and then I'll come back and give you an example of how we use this process.
Happy to jump in, Claudia. So as Claudia mentioned, we'll need at least 3-pass process to complete the prediction using machine learning. So what will be the first pass? So that's the learning pass, which will need all the past transactional data. So it could be granular to each transaction. It could be summarized data. In either case, you pass on that data to the data science engine, which will do a process of machine learning. So that is combining that with certain algorithms. So here the data scientist or the business leader should be able to choose those algorithms. Let's see how. And then the outcome of this whole process will be a model. Now, this model uh, created based on certain algorithms may be accurate for the business or may not be. So how do we test that? So testing will be the second phase of machine learning. So I could generate some test data, which is essentially very well generated if I use my recent past data, a subset of my recent past transactions. And if I run the model on that data, so I can predict some things for which I have the results already. So I can compare them, and then if the results are quite well matching, then you can keep the model that it fits your business. Or if the matching is not accurate, then you can redo the modeling. You can redo the learning by tweaking or changing the algorithms. Now, as a third step, actual production prediction. So you provide the real future data, futuristic data. Either it could be generated in batch or it could be coming in real time. So the machine learning process is completed by data science in phase 1, and then the data science engine will again come as a prediction engine. It's the two important activities that the data science engine does. So the prediction engine will come, apply the model on the real-time data or the futuristic batch data, and then it will predict the fields that we have asked for. So that will be the third phase. So Claudia, you can take up this to explain some real-life examples as such.
Yeah, thank you for explaining the process. Okay, let's take a look at this in real life. Let's take an example. Let's take fraud detection. In fraud detection, it's critically important to financial institutions, to insurance companies, to many, many companies, is the ability to detect a fraudulent transaction just a little bit faster than we could in the past. Think of how much money that saves a company and effort and just everything. So let's talk about that. How do we create a model? How do we use that in this environment? When Rajesh talked about all the past data, starting with fraud detection, we're going to take known fraudulent transactions that we know someone did fraudulently, and we're going to throw the machine learning algorithm at those transactions. And they're going to, the machine learning algorithms will look at each one of these transactions, figure out what are the characteristics of a fraudulent transaction, and then they'll build the model. And we'll test it, we'll test it, we'll test it. We'll make sure that it's as good as it possibly can be. And we'll come up with that model. Now, that fraud model is going to go into that prediction engine that you see down at the bottom. And what we're going to do as transactions, whether they're claims or ATM transactions or credit card transactions, whatever they are, that real-time data is going to come into that prediction engine, and every transaction that we get, we're going to throw the model at it. And it's going to say, do you have the characteristics of a fraudulent transaction? Yes, no, yes, no, yes, no, all the way down the line. Now, it could be a black and white thing. Yes, you do have a characteristic that is fraudulent-like. We're going to throw you out. You're going to go down a different path, and we'll earmark you as fraudulent. Or it could be just the opposite. Nope, you have none of the characteristics. Stream on through. We'll go ahead and process your transaction. Now, that's a little blunt, right? Because a lot of times, transactions may have a few of the characteristics, but maybe not all of them. So what if we could create a scale, whatever, 1 to 10, something like that? If you've got a couple of the characteristics, maybe you're a 1 or a 2, your transaction is. If you've got a whole bunch of them, then maybe you're an 8, 9, or 10. All right. Now, what do we do on this scale? If it's a 1 or 2, maybe we say, go ahead and let it on through, right? Let it go. It may have a couple of characteristics, but we don't think it's truly fraudulent. If it's an 8, 9, or 10, oh boy, you're going down a different path. We're pretty sure you're a fraudulent transaction. But those in the middle, 3, 4, 5, 6, whatever, somewhere in that area, where they've got enough to be questionable but not enough to be definite. Maybe they go into a third bucket that requires human intervention, and they have to actually examine the transactions, do some history on them, figure out what's going on, and then determine whether or not to let them go on down the normal path or be blocked and go into the fraudulent bucket. So that's an example of how we would use this process, a relatively simple process, but a really important process to determine, if nothing else, a fraudulent transaction. Now, you can apply it, like I said, to customers or to many other different things, but that's a really good example of how this works. But that's not all. Machine learning also needs a few other things, so I'm going to finish up my part of the talk with these next topics: data processing, what-if analysis, and visualizations. So let's talk about each of these. In data processing, the first step in anything is getting the data. Different formats, different sources, whatever it is, we have to get at the data. Then the second one is to simplify the data preparation by the business users. The business users can connect to a variety of data from multiple sources and make sure that they understand the data, they profile it, they prep it so that they can use it in their models. But they need access to a familiar interface, a BI-like interface. Then we have the built-in ETL that simplifies the data preparation work. Wonderful to have these things built in so that we can simply connect the data, use these built-in learning capabilities and so forth, the built-in data prep mechanisms. All these things ease and integrate the process with the end user actions. And then that last little bit, machine learning can use the data then at that point to bring out the accurate predictions, present them to the users as an interactive visualization, which we'll see in just a moment. But data processing is probably the heart and soul here. We've got to get the data to the point where we can now train the models. The next one is what-if analysis. What-if analysis is also critically important. All right, we have an outcome. What are we going to do about it? If we don't like the outcome, can we start to do what-if analysis? Well, what if we changed this? What if we did that? What if we didn't offer that and offered something different? So we have this ability to do the what-if analysis. Normally, some kind of self-service mechanism here used to select the right algorithms, the what-if parameters, and so forth. And then the business users can select from the variety of the algorithms. They can examine the results. They can determine, do I like this? Do I not like that? They can change the parameters. And that's the what-if part of it. Okay, here's what the prediction is, but what if we did something to change the parameters? And again, in Rajesh's demo, you're going to see him change parameters and then run it again and see what happens. So they can add and set values for these what-if parameters just to see how they would change the predictions. How are these things affected by these changes in these loosely correlated parameters that we have? Excellent example of what-if analysis. And then the last one, it does us no good if the data, the outcomes are unintelligible, if it's a massive number of numbers, for example. What we want to be able to do is visualize what's going on. We are all visual creatures. So the ability to take the outcomes from the models and be able to put them into some kind of visualization, a variety of visualization. We can look at the trends, we can look at the predictions, we can look at the confidence levels and determine, is this the direction that we want to go in? All right, my last slide then, and then I'll turn it over to Rajesh for the demo, is just a kind of a heads up, a getting started piece for you folks there. Most people, if you're not a data scientist, you may have no idea what algorithm will work best on a problem. But you don't have to start from scratch. Let the technology guide you. You know what the business problem is. The technology should be able to offer up, we'll try this algorithm. This may be the best one for you. and so forth. So let the technology guide you a little bit. You can get accurate results reliably, fairly, but again, keep in mind you may not need the best solution. In other words, yes, you could continue to train the models and change things and do this and do that and all sorts of things till you're blue in the face. Unfortunately, that will take time. And if you're under a time crunch, if something is going on that you have to react to right away, then maybe something that is good enough. It may not be as polished as the apple should be, but it's good enough to make a good, sound decision from it. So don't get to the point where you just are in sort of this analysis paralysis mode. A good answer may be good enough. And then my final piece of advice is to create some kind of a checklist. It always helps to have just a bit of a checklist when you're working through a machine learning problem. For example, the first thing you always should do is define the business problem. What is the business problem you're trying to solve? If you cannot write it down or speak it out or whatever, then you've got a problem to begin with. You've got to know what the business problem is, because that's going to lead you down the path of getting the right data to answer that problem, preparing that data, making sure that it's solid enough that we can now start to train our machine learning models. Spot check your algorithms always. Are they running efficiently? Are they running correctly? Are we getting too many false negatives, too many false positives? Make sure you do check on those algorithms and improve the results. Tweak the models. Change the data if you have to. And then, of course, the last thing on the checklist is, how do I present this data? How do I visualize it so that people can understand exactly what I'm doing here? And then you can move on and deploy that model. All right, so that's my part of the presentation. I'm going to now turn it over to Rajesh. He's got a very good demo of what Intellicus can do. So make sure that you follow closely his demo. It's a good one.
Thank you, Claudia, for a very nice presentation and a piece of advice there for everyone. And checklist. That's it. Hi, everyone. I will begin with the basic product architecture of Intellicus, so that when I use certain screens to do certain activities, we know what I'm trying to do, in which part of the product, and so on. So logically, Intellicus is divided into 3 layers. The lowest layer shown here is for the system administrators for setting up the connections, security, user management, and so on. So as is discussed, both BI and the data science activity requires a lot of data to be coming in from multiple sources, multiple source of business, the data, wherever it is generated, could be multiple ERPs and so on. So that connection is all set up by system administrator, for example. Then in the middle layer, we have got data administrators and data modelers who would actually design or have syntactical programming if they need to be done. This is essentially like writing SQL layer, SQL syntax, or designing the models for cubes and so on. So this level exactly processes the data. So it could be rendering of certain reports, it could be aggregation, pre-aggregation, grouping, sorting of data, and so on. And also in the same layer, we apply the machine learning part. And then at the topmost layer, which is meant for the business users, there it's all drag drop, it's all visual effects. So that layer should not be bothered with any kind of programming or configurations and so on. So we see all the reporting thing, the report objects or visualization objects that are being in the topmost layer, and then anything that is configurable in the mid layer today. So we'll be taking up 2 different data sets for today's demonstration. One, I'm taking up housing prices data of one of the counties in the US and see how the pricing trended in last few years and how we can predict it for next few periods, which is for next few years. Then I take up another data set. I'll be showing different features in the earlier data set and this one. Here we'll take up the power consumption prediction of a commercial place where I'll take up the cooling tower, the power consumption data. The data points here could be all the internal and the external weather components and so on. So that's what I'll be taking up. So let me begin with my. So what you see here is Intellicus portal. I will click on the Explorer. So you generally see two types of objects when I open the Explorer. One you see as a query object, and other is report, a visualization report. So if we go to the query object, essentially what a query object does is it provides an abstraction layer over the complexity of the data and provides a simplistic layer for the business user. Now the query object is a semantic layer which is workflow enabled. If I just double click to open it. So if you look at the structure of this query object, so on the left side it has got all the input steps. The data could be coming from one or more places, and then it's arranged in a workflow, and then it could be multiple processing steps. I've taken only one type of step right now, which is relevant for us, our demo today. It's the data science engine step. And then the right side, you'll see that as an output. So that output could be used for visualization or loading the data to any target data source, database. Now I click on one of the data sources. So this data is essentially, it could be coming from any place, any RDBMS or file or Excel, whatever source. Now, if I look at this data, what does it show? It has got the housing unit sales transactions for last 5 or 6 years, as I said, and it has got more than 70 different attributes that are recorded. So it has got the type of construction, street access, alley access, the size, various types of size, roof type, whatnot. All those attributes are there, and we don't know which particular attribute could be causing the important pricing difference and so on. So, and also at the end, if you look at the end, what we have is the year of sale for the past and the price. Just scrolling. So there's a huge list of attributes right there. Yeah. So these are all past transaction data, as you see there. Now this data is supposed to be used for learning or the training purpose. Now I will select the second data set. Just let me scroll up. So I click on this second data set, which is right now named as spread prediction. Yeah. So this is the futuristic data set. So I can have any number of attributes out of those 70 attributes that we mentioned in this data set, and essentially this will not have the sale price. So for the year of sale, we will feed the data as data as the future year dates. So if you see here, the years old, we have kept some future years. So we want to, this particular type of property could be of which price in the future years. So the next step that you see here is the data science step. So let me scroll up. So what we see here, so this data science engine step is supposed to, in phase one, it is supposed to pull the training data and then conduct the creation of model. It should pick it up. As soon as the model is created, it should pick up the prediction data and start applying the model on the incoming data. So let me click on edit. So this is a script right now which is automatically generated, and this will be further abstracted for the end users. So this script has got the algorithm name which will be used for machine learning, which could be changed, and also the number of fields that could be causing the price. So essentially we could use all the 70 fields for the in the learning process. We don't know which particular attribute could be actually affecting the price and how much. So if you go to the next step, that the predicted output, which has got the resultant fields. So when we actually run this query object, that would populate, process, and then populate this step. So this would have all the field names in the user-friendly way. Now I will open this report, which essentially uses this query object, and when I actually run this report, that's when it runs the query object in turn, and then it will cause the whole process to happen. So now it's actually picking up the 60,000 plus past transactions, doing a machine learning, building the model. Then it's now applying that onto the futuristic data, the prediction data, and then it's creating the visualization also. So what we see here is average price. So let me also show the design of this report. This is end user layer, so this should be very easily designable by the end user himself. Now if I just click on edit mode, let's see if the user is now looking at the design of this, and click on this pencil edit icon. So designing this chart visualization is as simple as I drag the sales price and set the function as average, the predicted sales price, and then I've got year of sale. So year of sale, I just dragged it from the available fields from the website. That's it. So this should be the level of simplicity for creating reports or visualizations over any complex data processing that happened in the background. So let me close this and go back to. So the blue bars that you see on the left side, they're all historic data. And then the lighter blue bars that you see on the right side are futuristic. They are predicted. Now, one important factor is that let me check this data. How does it work for selected set of data? I don't want an average price for all types of housing units. So I would want to predict it for a particular type of unit. Let's see that. Now, when I open this ad hoc filter screen, what I see is how am I using, this is mostly the prompting screen. So how should I use the data science uh, engine right now? So the first stage, what we use is training and prediction at the same time. Now I get an option to either use it only for prediction. Now, if the model is already available, I don't want it to train again. Now use the model and even to uh, predict on a subset of data. So now let me apply some filter and select the fields. Select zone classification. It has got 3 or 6 different types of housing units. So one is residential, high density, residential, low density, and medium, and so on. So let me pick one type of data. It will be a subset of overall data and apply. So right now in this stage, the model is not being trained. We have an already trained model right now, and that is being applied for a subset of data and a particular type of data. So this visualization has been created again. So what we see is in the past also, there has been a good, very good fluctuation in the pricing. And then in the future also that fluctuation is predicted. And what we see here is it's peaking out its price in 2019, and then it's dipping in 2021 and so on. So one could take a decision as to when could be a good time to sell the property versus buy the property and so on. So if I look at another set of data, the same model being applied to another set. Let's see how does the same model apply. So I'll go and open the ad hoc filters again. So this time I will choose residential low density housing. So it's applying that same learned model again. So here we got. So if you see here, even historically, this has been much stable pricing. So and the prediction is also much stable. If you see here, 2022, it's a decline in the price compared to the high density pricing. So the same model has got information specifically drawn about each type of housing. When the attributes changed, so it's showing a decline from 2021 to 2022 versus in the high density what we saw to the increase in the same period. So I'll take up the next data set for example for the sample demo. This is the power consumption data. So I'll run the report now. Now you understand that. So this is a visualization report that I will run directly. Now you understand that this will run the query object in turn to process the data. Need to double click on this report. So it's doing the learning as well as predicting. So this report is designed on a monthly consumption total basis. It could have been it's transactional data, daily data. It could have been designed for daily, weekly, or quarterly basis. Now, if you look at the prediction analysis screen here, so the prediction model is the algorithm is being selected here, written here. This is the auto-generated prediction script. Now, what we can set is the data points. So for future, we have asked for 7 future data points to be predicted. Now, when I do the grouping of monthly versus quarterly, it can do different data point predictions. So also one important aspect is that let's see how this design is report is designed. So in the y-axis we have used this total power and the sum of it, and in the x-axis we have used date time and we have grouped it by month. So if choice be, even the business user can choose how this whole report and the prediction model should work on. So it should be weekly or daily, so that level consumption can also be generated using the same report. Now, what else can be visualized? So what we see here is, the month-wise sum of results. Now, along with that, there are 7 to 8 different parameters which we call as independent variables that we have used in the algorithm. Now, all those algorithms, all those independent variables can be seen here right on the when I hover the mouse on a particular bar. So in January, what it shows is that how the temperature is overall trending and what was the temperature in January and how and where so on. The yellow data point is showing which is the affecting factor for that particular month. And let me also check for the highest consumption month, which is July, and what were the factors there. So this will also give us idea about how does those factors behaved when this consumption was at this level. Now let's also see the same thing for the futuristic predicted values. So here if you see that the temperature was quite high and the dew point was very high, and then wind speed was low and so on, the high consumption. So what has happened here is the futuristic value also, prediction value also, all these weather data points are also predicted. So one important factor in this processing that Intellicus does is, now for future you may not have all the values, all the independent variable values. So based on the trend, they are also predicted first. And then those predicted values are used to predict the resultant power consumption. Now, once that is the fact, then I may need to tweak the self-predicted values. That's when the what-if analysis comes. So if you see here, these are 7 different variables that have been used. So we saw that the wind speed, dew point, and temperature were the important factors that factored the power consumption. So let me tweak these. Let me increase the wind speed by a certain percentage. So then 15% wind speed, and then maybe 15% dew point I increase. So these should ideally cross each other. Then I would reduce temperature and see how does it happen. How does it affect? So now I apply. So now again the data modeling or learning is not happening. The model is created right now, and then now the prediction engine has run. So what we see here in the January-February month where the consumption was already low, that did not affect much. Whatever changes I did, that did not affect much. But in the month of June and July, that affected quite drastically. So wind speed, having a higher wind speed really caused the power consumption to be low. Having quite 10% less temperature, that had a certain change. So the factors for this particular consumption may be a lot of internal elements also as to which all appliances and which all factors that we are using and so on. So that's one aspect. Then if we look at this whole process, one important thing that I want to do is preserve this as an evidence for certain activities, to share this insight with the right set of audience in my organization. So that's when I need simple sharing kind of a environment. So I could actually schedule this whole thing and get this report generated in my email, or I could publish this to a set of users, or I can just, for quick demo here, I can just export this into a PDF file and use this. So there are many output options. Let me choose PDF. And this seems to be a wide display report. So let me do a landscape. And then export. So the PDF is right there at the end of the bottom of my browser. So let me open that. So this past data and the future predicted data, so that's available as a PDF, simple PDF. So I can further format this report, add more parameter values and everything to make this a comprehensive full-fledged report. So that's the aspect that I wanted to show. I'll give a handle back to Shilpi.
Sure. Thank you, Rajesh. Thank you for taking us through the demo. We will now start with our Q&A session. As we discussed some of the questions that we have received while the session was on, if you have any more questions, please send them to us through chat or through the Q&A panel, and we'd be happy to answer those. Okay, to get started, we have received the first two questions from Sean Webb. The first question is, defining the learning algorithm seems to be the most important yet most difficult step. Won't that step always require an experienced, skilled data scientist?
Claudia, I want to begin with your answer and then I can add.
Oh, all right. Sure. Thanks, Sean. I appreciate the question. It's actually a very good one. And the answer is the algorithms need to be created by somebody who knows what they're doing. The usage of the algorithms is perhaps the part that does not require the data scientist. I'm going to let Rajesh talk about what Intellicus has in terms of algorithms and that sort of thing. The one thing that I would recommend for anyone who wants to go down this path is perhaps a little bit of education goes a long way. I would recommend that anyone who wants to climb into these more advanced analytics, it wouldn't hurt to take a beginner's class in fill in the blank statistics or machine learning or advanced analytics or something like that, just to get a feel for how these things work and what looks right and what doesn't look right. I think anybody that's coming in cold would have a tough time trying to figure out, well, is this model now running the way it should be running? But that's just, it takes a little bit of knowledge, not a lot, but you ought to have some. All right, Rajesh, your comments?
Yeah, it's a good question, by the way. So there are two things that Intellicus would be providing. One is, we are generating the script right now. We would abstract it going further, in the sense abstracting it by putting the scripts under some selectable drop-down options. So you select the fields by drag drop, and then you just choose all the algorithm that you want to run using a drop down, and then you don't have to worry about even the script. Now, if you are educated, then you can open. So that is the model that Intellicus will be going with. That's one thing. Second thing, what as an OEM or embedded BI provider, what we would also encourage is you being able to uh, create or generate a model and then ship it to your customers or users so that they can use it. As a developer or as a vendor, you could generate a model and then ship it along with your data definitions and so on.
Hey, hope that clarifies your question, Sean. The next question that we have here is, how do you determine applicability of historical data? Or correlation analysis using the learning algorithm, is it?
Yeah. Claudia, can you?
I'm not sure I quite caught the question. Could you repeat it again one more time?
Yeah, what's the applicability of historic data in the whole?
Oh, applicability of historic data. Oh, got it. Okay. Yes. How do you determine the applicability? Well, you'll notice in my fraud example, I said known fraudulent transactions. That's always a good start because you know that's what you want. The business problem defined the data itself. If you're looking for the next best product for a customer, then you're going to have to look at data that deals with customer behaviors, buying behaviors, propensity to buy, types of products they like, and so forth and so on. So I think that's why I insisted, Sean, at the beginning that please define what the business problem is, because from that will fall out the type of data that you're looking for. If it's a medical history or a diagnosis, obviously, then you have to look at past cases that have similar characteristics and so on. So I think the business problem, the more you define it, the better you define it, the better your choice of, or the more it will lead you to the correct data to use.
I would add to that, Norman. So data is really critical for this machine learning. Without historic data, it's really difficult to imagine machine learning and modeling to be successful. There are two types of possibility here. One is you can have your own available data, which is very really good for your business. But also otherwise, what people do is if there is public or semi-public data available in a common domain, so that is used for learning purpose and it could be applied privately for prediction purpose. One very good example is, if Apple has given an object recognition algorithm, not everybody needs to learn from their own set of pictures and objects and so on. So there is a learning that happened on public data and which can be used very well privately.
That's a good point. A lot of external data that we can bring into these models.
Okay. Okay. So the next question that we have here is there any limit to the number of parameters for what if analytics?
That's for me. Even from the generic point of view, there should be no limit, and in Intellicus also it should have no limit, and it's the matter of how user friendly it will be when we have 70 or 50 parameters listed on a page. Technically, it's possible, and yes, the business user can actually tweak any combination of those to actually to create the what if analysis data.
Okay. All right. And the last question that we have here is that can we use machine learning algorithms for data cleansing?
Ooh, can I start? Absolutely. I would love to see machine learning algorithms for data cleansing. We are starting to see that in data prep technologies and ETL technologies. Rajesh, I'm sure you have an answer in terms of Intellicus here.
Yeah, fine. I think one of the most popular usages of regression algorithm is for data cleansing. So we support that. So that's how we can actually, both identify the missing values or uh, based on the cleansing, identify the wrong values and correct them also. Yeah, that's a popular usage.
Okay, all right. I guess that's it for today. Thank you once again, Claudia and Rajesh, for taking us through this presentation and demo. And thank you, everyone, for joining us in and being a part of this demonstration with Intellicus. Have a good day ahead. Bye bye.